All right, everybody. So we're going to do the same problem twice, once with factoring and once with quadratic formula. Before we start either of these two problems, I need you to know that you need to have them equal to 0 before you start. I did this on purpose. I put the 16 on the other side of the equals to remind us all that we need to subtract the 16. And before we do any factoring or quadratic formula, it has to be equal to 0. So I have x squared plus 6x minus 16 equals 0. Everybody okay so far? Okay, this is a box and diamond problem. Okay, so to remind you, the x squared, the first term goes in the first box. The last term goes in the last box. And that's the first part of your setup. So step 1, first term in the first box, last term in the last box. Step 2, you're going to multiply these two and put them at the top of the diamond. So this becomes negative 16x squared. And the middle term, the b term, goes to the bottom of the diamond, which is 6x. Okay, now here's the multiplication tables part. What multiplies to be negative 16 and adds to be 6? 8 and negative 2. Great job. 8x, negative 2x. Okay, then I like to narrow my focus down to the top two boxes and say, what is the greatest common factor of just those two, which is x. X times x is x squared. X times 8 is 8x. X times negative 2 is negative 2x. And then I just do a little check in my mind to make sure that that last box makes sense. Negative 2 times 8 is negative 16. Okay, and the next step in the problem is to write the two factors from the box. You guys okay so far? Okay, now because it says solve, we do the zero product property step. So x minus 2 equals 0. X plus 8 equals 0. Plus 2 minus 8. Done. Okay, are there any questions about solve by factoring before we move to quad formula? Are you sure? Okay, so write the problem down again. Same problem. And again, we have to subtract 16 from both sides before we start. I'm going to solve this using the quadratic formula, but what will my answers be? 2 and negative 8. I already know the answers. It should be 2 and negative 8. So I'm just going to solve it in a different way. So write the quadratic formula down over here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And this one's going to be a nice one because it comes out to whole numbers. So this is a great place for us to start. The first thing I like to do is I like to list what a, b, and c are. A is the number in front of the x squared. When there's nothing there, it's 1. B is the number in front of the x, which is 6. And c is the constant, which is negative 16. Okay. And when you put the numbers into quadratic formula, use parentheses a lot. So x equals negative b. So I'm right here. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay, now at this moment, either get your graphing calculator out or go grab one. Okay, and what I want to do is I want to type in the part underneath the square root exactly how it looks. But the graphing calculator's got a couple of, we got one quirk I want to make sure we talk about. So I'm actually going to type the parentheses. The parentheses are above the 8 and above the 9. So parenthesis 6 squared. You guys see what I'm typing? Just the stuff under the square root. So 6 squared minus 4 times 1 times, and I need to put negative 16. Negative is down here at the bottom underneath the 3. Don't put minus, put negative. So hit this button for the negative down here, not that one, this one. So it should look kind of smaller and up higher a little bit. Okay, so this is what should be typed in. Parentheses 6 squared minus 4 times parentheses 1 times parentheses negative 16. And then hit enter. If you got anything other than 100, you didn't type it in right. Okay, so I put negative 6 plus or minus the square root of 100 because all of that came out to be 100. And then I did 2 times 1 is 2 on the bottom. Okay, what is the square root of 100? 10. So negative 6 plus or minus 10 over 2. Excuse me. Okay, now make me 2 arrows. Negative 6 plus 10 all over 2. Negative 6 minus 10 all over 2. So you break it into 2 problems. One of them has the plus and one of them has the minus. And this one is x equals 4 over 2, which is 2. And this one is x equals negative 16 over 2, which is negative 8. Were those the answers that we expected? Indeed. Okay, now underneath this, you're going to write this and you're going to leave me the rest of the page. Okay, you're going to write solve by complete the square and you're gonna write the same problem, except for that you're gonna leave the space there, and then at the end of chapter 2, we're gonna come back to this paper, and we're gonna solve this problem again by complete the square. But I'm just having you leave the space in your notebook now. We're not doing complete the square today. Just those two guys. So just write this down and then leave some space for later. Okay, and once you get this set up, we're not done with the notebook, but just scooch it off to the side and get your packet. And find warm up number 12. Does anyone need more time with the screen as it is right now? Okay. All right, so warm up number 12. This one I'm going to tell you is not factorable. It requires the quadratic formula, which is why we did the notes first, so I could remind you about the quadratic formula. And this one is not exactly the easiest one. Um, it's probably the worst case scenario problem. So just so you know, this problem right here, so the one we did in the notes was the easiest quadratic formula could ever be. This problem right here is the hardest quadratic formula could ever be. So just so you know where the span of the types of problems are. Okay, so the first thing I'm going to do is say A equals 11, B equals 10, C equals 10. Does that make sense to everybody so far? Okay, now I'm going to put the things in the quad formula. The problem has A in it, so I'm going to say A equals, which is really awkward because this is A, but just ignore that. Okay, negative B plus or minus square root B squared minus 4AC all over 2A. Okay, step 1 is done. Step 2, go to the graphing calculator and type this in with the parentheses. So just the way it looks. 10 squared minus 4 times 11 times 10. Just type it exactly the way it looks. You're going to get a very unfortunate answer. Yeah, it's not only negative. Yeah, and it's big. That's why I said this is the worst case scenario. Okay, so we're going to say A equals negative 10 plus or minus square root negative 340 over 22. Okay, pausing there. Everybody okay so far? Okay, now I'm going to immediately make this negative 10 plus or minus I root 340 over 22. So if you forgot, the way that you get rid of the negative under the square root is you put an I in the front of the square root. Who already knew that? It's been a while too. Okay, now that's not even what makes this problem bad. We're not even to the bad part yet. The next thing is that 340 is simplifiable. Come up here to the top, and we're going to make a factor tree. 340 is 2 times 170. Oh, 20 and 17 is fine. This is 17 times 10. And this is 5 times 2. Okay, did I get down to the primes? Yes, the primes are 2, 17, 5, and 2. Do you see twins? Twos. Circle one, cancel the other. Okay, now this is how the etiquette is. You take the circled 2, that comes out in front of the I. So instead of just I, this becomes 2I from the circled 2. Square root, and then the 2 leftover ones get multiplied. So 17 times 5, right, over 22. And I'm going to rewrite this again just because it's our. Okay, and now you really, really want this problem to be done, and so do I, except for that it's not. So this one is reducible. Now you have to either reduce all 3 of these numbers or none of them. These are all divisible by 2, so I'm going to make that a 5, that a 1, and that an 11. Did you see what I did? Okay, so I have negative 5 plus or minus I root 85 all over 11. That is as bad as that problem will ever get. So if you can do that one, you can do all quad formula problems, basically. Super, super high difficulty level. But the one that we did in the notes is like the baby one, right? Does that make sense to you guys? Okay. Yes.
There is no way to get rid of the I.
No, it's there forever now. He's like a little parasite. It's just, and you can't graph it either. Yeah, it's just living there. We're going to spend a lot of time talking about what that does, but this is a parabola that does not cross the x-axis. It floats above or below. So there's no x-intercepts. That's why it's they're imaginary. Okay, now we're going to do number 16. I know we have so much to do today. Okay, 16 is another problem with eyes. This one needs a box. So I made a 2x2 box and then put one of the factors on the top and one on the side. It doesn't matter the order. This is negative 49, positive 14i, positive 35i, and negative 10i squared. Okay, so I have negative 49. Then I combined like terms. So I made that positive 49i minus 10i squared. Okay, if this problem had any other letter in it than I, it would be done. But I is very special because I squared equals negative 1. So you hunt through your problem to see if you find any I squareds. We have one right there. So you take your I squared and replace it with negative 1. Which makes this plus 10. Okay, when you're ready, flip to the domain and range side, please. Okay, number 7. Does it pass the vertical line test? No. If I drew a vertical line right here, wouldn't that hit the circle twice? Do you see it? Okay. Okay. Now for the domain and range, for the X, the most left spot is here, so I'm going to put a dot there. And the circle exists here, 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 and then the most right spot is there. This is one of those that I refer to as a Baymax graph. When you have a Baymax graph, you write a compound inequality. So negative 2 is less than or equal to x is less than or equal to 2. Okay, now I'm going to draw on the y-axis for the range. The bottom is here of the circle. The top is here. So my circle goes from what to what? 1 to 5. Great. Okay, number 8. Is this a function? Yes. This is another one of those drawings where the arrows look like they're just going up, but I promise you it's going left forever and right forever also. It's just going to be really steep. So going left forever, the graph exists here, and it's going to go right forever. What do we call that? All real numbers. Okay. The range, you can tell it's going up forever for sure. It exists here, it exists here, it exists here, and the bottom is here. This is one that looks like a ray. And when you have on your axis something that looks like a ray, you write it like this. You write like a regular inequality. So I'm going to say y is greater than or equal to 0. Okay, now can you please flip your, when you're ready, flip your packet to the stamp sheet side and then just leave that side up. And then get your notebook back out.
Oh, yeah.
Okay, everybody, so we're gonna play with the graphing calculator again today. Today's gonna be very similar to yesterday where I'm gonna do a problem and then your group is gonna do a problem. But this is a completely different one that you haven't seen before, I don't think. Unless you're repeating math 3, you haven't seen this before. So go ahead. Set this up, but then we're gonna get most of it right from the graphing calculator. Your table numbers, because number 30 is the one you're going to do with your groups, and it's going to have a table number involved in the class. Okay, so this is called a rational function. You've probably never seen a rational function before. That's okay. It's your first time. Um, just like the square root functions from yesterday, you probably never saw those before either. That's all right. What we're going to do is we're going to type this in the graphing calculator and kind of steal the table out of there. But there's something that you need to know that's really important. When you enter this into the graphing calculator, you have to put parentheses around the denominator. Okay, again, when you enter this into the graphing calculator, you have to put parentheses around the denominator. If you don't, your graph will be wrong. Okay, so everybody grab your graphing calculator. And hit the Y, so turn it on. And then hit the Y equals button, which is at the very top left. If there's anything in there, clear it out. So just hit clear, which is over here underneath the keypad. Everybody with me so far? Okay, now what you're going to do is we're going to type this function in. So you're going to do 1 divided by parenthesis x plus 7 parenthesis. And remember the X button is right next to the alpha button at the like right there. That's the X button. So you should have 1 over to 1 divided by parenthesis x plus 7 parenthesis. You'll have it all wrong if you don't use the parentheses, I promise. So make sure you do that every time you do one of these rational functions. Okay, now hit second graph and scroll to where -12 is at the top of your screen. So second graph, and then scroll to where -12 is at the top of your screen. How are we doing? Okay, once you get here and get your table, just copy your table down onto your paper, right out of the calculator. We're going to round this to the like hundredths place. So I'm going to say -0.2, -0.25, -0.33, -0.5, -1. There's an error. We're going to talk about that in a minute. -6, 1, -5. I'm hoping that you guys notice the symmetry of the decimals that you're writing down in your table. Do you know what I'm talking about? The numbers are starting to repeat. Okay, now I want you to hit, when you have your table situated, I want you to hit the graph button and just see what this thing looks like. This is what a rational function looks like. It looks like two exponentials. One of them is in one quadrant, one of them's in another quadrant, kind of. Okay, and we're gonna graph this in a very specific way. When we do the graphs for these, the first thing you graph is the part where they separate. Do you guys see where the error is in your table? That's called an asymptote. Okay, so I'm going to take a different color. You guys don't have to. And I'm going to take a straight edge, but also you guys don't have to. I'm just nerdy over here. And I'm going to go back to -7 where my error is. And I'm going to make a dashed line to show that asymptote. And then I label the asymptote with its equation, which is x equals -7. Okay, now I have a question. If anybody was engaged yesterday, you would know that there is a way that you could figure out where the error would be without looking at your graphing calculator. How can you figure out where the error would be from just looking at the equation? Yes. What? Look at the 7. Okay, so what you can do is do x plus 7 equals 0, minus 7 from both sides, x equals -7. That will always be the spot for your error. Okay, now we're just going to graph the rest of the coordinates in and try to make the curve as best we can. Okay, now when you sketch these in, and if you were in my Math 1 class, I apologize because you're going to hear me say something that I've said a bunch of times in there. Try to leave a little bit of daylight between your graph and the axes. So don't try not to touch the asymptote. So what I mean by that is if I'm going to make this curve, I'm going to come along here, try not to touch the asymptote. And then try not to touch the axis. So I'm trying to leave a little bit of daylight, is what I mean, in between the graph and the axis and the graph and the asymptote. Okay, is anyone out there just screaming in their head, Mrs. Sabat, there's actually two asymptotes in this graph? There is. Can you guys tell where the other one is? It's on the x-axis, yeah. Okay, so I'm gonna ruin my pen, which is just so sad. I'm gonna come along and try to dash over top of the x-axis. Does anybody know the equation of the x-axis? It's y equals 0. All right, everybody, we have one more thing to do for this problem. We're going to describe it, and then I'm going to have you guys do one in your groups. Okay, the type is a rational function. The shape, you've never heard this before probably, is a hyperbola. This thing is called a hyperbola, the like swish swish guy. That's his name, hyperbola. Okay, now what you're going to do for the domain and range, this is easy, domain and range for these. I like them. You're going to say the domain is all real numbers except x is not -7 because that's where your vertical asymptote is. And for the range, you're going to say all real numbers except y will not be 0. That's where your horizontal asymptote is. It is a function. We don't need to write that down because I wrote rational function, so I sort of spoiled that. X-intercept. Trick question. None. Y-intercept. 0, comma, it's right here. 0, comma, 0.14. All good, all good. This graph is decreasing. So it's weird because if you start here, it's decreasing, and then it pops up here and it's decreasing. And then it's also called discontinuous, meaning that you have to lift up your pencil to jump to the next piece of the graph. Okay. So what I want you guys to do is I want you to go back to y equals in your calculator. Everybody find their calculator and go back to y equals. Okay, and what I want you to do is I want you to change this plus to minus, so subtraction, not the negative, the subtraction, so make that minus. And then you're going to put your table number the number of the thingy that I put in the middle of your table, I'm gonna say 8 because I'm the last one over here. It only went to 7. Okay, do you see the thingy in the middle of your table? Okay, so you're gonna do this exact same thing with X minus the table number. You're gonna make a table. You don't quite have to make it as big as you did. Sketch the graph, dash the asymptotes, and describe. And while you're doing that, I am going to come around and stamp your 23 through 25, 28. Does anyone need clarification on what I meant by table number and things? It's going to be the same thing, it's just shifted. So when I come up to your table, if you could just quickly flip your notebook back to 23 through 25 and 28, that would be great. And if I didn't stamp your number 13 yesterday, I think I stamped for everybody, but.
No, I didn't. I'm sorry. So you're struggling. I'm the sophomore. I was right now. Oh my No, and That's not bad. Yeah. It's like 20 days in my life. But I play the next one.
Yeah, just right.
All right, make sure to see a little bit of daylight. Make sure you do. Put this file, that's it. Yeah, exactly. You're getting a good I can't consistently like 6. I'll get like a 6 out of 8.
No problem. I always have the.
Great say.
Oh. Don't read it like. That's how it's good. I did think. 13th, okay.
It's not bad.
Oh, yeah. So I didn't offer. So I got a notebook, but. I'll read it on. That'll be great. Also, this. Perfect, okay. And then. No, I mean, you just said. It looks like. Okay, got it.
This shit is like not. Oh, wait, where did It's like shit that
Oh, the way it raised, it's not too opposite. I mean, that's what the rest of the world. Oh, yes, that's right. The one with the. Yeah.
No, not so. No, I don't know where my. I keep seeing like go. We did the stamp.
So it can. Perfect. Yep. Okay, real quick, I have to help people get into the ebook, but, I want you guys to know tomorrow we're taking the math test. I need everyone to bring a chart Chromebook. And I need to let you know that I am going to use the results of your math test to make sure that you're properly placed in this class. That means that if you didn't do great on your quiz and you don't do too great on your math test, we're gonna have to talk about your schedule. So I'm telling you, you have.
No, I'm saying that instructions are on the side here. I don't want variation. We didn't have that. We're using everything. Like, you have to be. Why don't you go to I was saying yesterday, Frank, you're going to the meeting. I get kicked out. Okay, I don't know why I like. No, I had this privilege. I had this privilege. I don't care. I don't know. Take them out. It's such fun. Seriously, indie content performing. Oh, yeah, we can do it like me. I'm pretty sure she should have around there. I have oral. My apologies. Yeah, I think no one does it all the same way. Yeah, I did. Well, just the, it's like, just the math test, like, it doesn't adapt. Yeah. I haven't got that. Like 49. Oh, yeah. The math test, bro. Oh, I don't know. I got like other people. Yeah. I feel like DJ Ego, Peter Gilly.
I know your phone is what you look at, I guess I have you like. But that's not. Well, it's not the whole one, starting tonight. So you just look at this and then one has 25 day and then like, or like break it apart. So it, I think it's on your. I just solve it. Bye. Oh, sorry. Your assignment is always right. So this is what we did in class. You do 35, 36, 37, 38, and 41. Usually 4 problems. Thank you.